So on your remote, do you send and receive LoRa messages?
Yes, I do.
And so I was looking, I was trying to find examples of that, because I was thinking, hey, if you've got to implement, what I'll call a heartbeat function to say, I send a packet, to, from the joystick to the tractor, or I send a packet from the tractor to the joystick, and I want on the joystick to have a green LED that says, I'm talking to I'm able to communicate, and then I've got a valid radio connection. I was thinking through how to do that, and I was looking for examples of code on how they actually implemented that send and receive. And I'm like trying to find it here. So you do that?
Yes, I do.
Do you mind walking through how you do that?
Well, first I just started with one of the examples from, I started with the Adafruit libraries, which I don't know if it really matters too much what the libraries are, but they might give you different examples. And basically I just found one that it would send something and then wait for a response to come back. So in your code, you've got something that says, on the end you consider your transmitter right now, you're going to read up your data and say, call a thing that says transmit or broadcast or something. And then I assume it just immediately falls back through, and you have like a loop or something that goes around and around. Now at the other end, you've got something that says call, either says call the receive function, or it says if there is data been received, then process it. I'm not sure which way that works. You basically just combine those two together. You say read up your joysticks and switches and say transmit, and then it follows through the next one. It says wait for data to come back. It just says wait to receive data. And depending if that has a timeout or not, you want to put some kind of timeout on to say, I didn't receive anything, therefore it falls through the loop and goes back and does it again. So it was just a matter of, and somebody had already had an example that combined those things together. I was going to go look at Adafruit here and see if I can find out. See if I can find that. And the biggest problem is this is on I think on one of the Linux computers that I don't use anymore. So I'd have to go actually track that down and find the code for it. Now, let me look at this board. Here, I'll put something up for you to watch. So this is this is the one that's in my actual remote. So it's just a single board with a radio and essentially an Arduino processor, all Arduino type processor all built together. And if you go down here where it says, so as a reference, if you look at say this one right here, this is what you need to make it run. You got the board, and you plug a battery in directly if you want to. Although I ended up going in through the USB cable to power it. So I've got one of these USB charging batteries that just plugs into there to power the thing. I do have one of these batteries laying around. I don't even know where it is. But essentially, then you hook up, either analog inputs or digital inputs to this, and that's all you need at the one end to make it run. So let's go down here where it says description. Somewhere it says making it run. Let's see what this one gives us. But they've got the tutorial that takes you through and says, here's how you do the software, data sheet. Maybe it's this one. Using the radio. And let's see, do they show us examples here? Library. So this radio head library, I think, is what everybody uses if you got that kind of radio. Regardless of what your base board is, I think everybody's using that. And basic RX and TX examples. So here it's given the examples here. I'll just put this up. That there. Put that there. And they're saying when you start your code up, you got to configure it to the type of processor and the type of processor board and the frequencies, the band you want to run and all that kind of stuff. So let's see. I assume the one that says this says RX and TX example. I assume one end is transmitting, one end is receiving, which I think is what you're doing right now.
Yeah, that's the simple one. What I want is
So it says here they're setting up the
on
transmitter.
one module, send and receive.
Receiver example.
And I have one instructable that I found. It's a little bit of, I don't know if it's Spanish or Portuguese.
Was it a web page or like a GitHub? Because if it's a web page, you can usually go to Google Translate and they'll attempt to translate it for you.
Oh, it's not that bad. Most of it's in English.
I see this page I got here doesn't tell me everything. So it could be that. Let's see, send a reply and hello back to you. Maybe it's got enough stuff here to do what you want. Receiver code should the message. If it's saying hello back to you, I assume it's transmitting, it's receiving and transmitting. So it says wait for packet to send. But I'd have to dig out the code, then I could, get a better idea how it works. And it could be just looking through the code here. Let's go back up here where they said the transmitter code.
Yeah, so wait packet send. Maybe that's what the
receiver example. So let's see, this would be, yeah, so let's take this is the receiver side. This is what I have on my robot right now. You really should swap it around, as I've mentioned before, but for right now, example, blah, 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 create some message. So somewhere here, there's going to be, he's going to have like a setup section, and then there'll be a loop section. There's all configuration here, void setup. So it's going to start up the thing. Just print a local message. Okay, loop. So it says if that is available. So I guess you'd have to look up, see what that's actually. I don't know if that means that it's just checking to see if the board is communicating, or
yeah, if the channel is open, I think.
Okay. If receive buffer link. So right here, this is sitting here waiting for something to happen.
So that thing, I've got something in I received something.
Yeah, receive that, and so you send a reply. So this right here is doing both. It's sitting here waiting for something to come in, and when it does, then it turns around and sends the hello back to you message back to the other side. So this is talking both directions on the receive side. Let's go back to the transmit side. So on the transmit side, there's a setup loop. Wait for 1 second between transmits. Could also sleep here. Says transmitting. So they're just putting a text message that says hello world and something, and then it's going to.
And it says waiting for packet to complete.
Sending. So right here, this RFM95.send is where it's going to take that data you just loaded and send it out.
One byte at a time.
and this wait packet sent. So that's just going to, you know, it sends it, then the waits till it's all done, and then it's going to go into a, it says waiting for reply. And it just simply, it's going to call the, it says wait for the data available, and it's got the timeout on there. So it's got, that's doing everything for you. It sits there and waits for a reply to come back. If it doesn't get one, it times out, and down here it says receive failed. So this is basically the code that you need to make it work. Now, I don't know if this will drop right into what you have or not. Is yours in Arduino C code, or is it in MicroPython?
Arduino C.
Then that, you know, theoretically, you know, just cutting pieces of lines out here might work for that, or just go back to the examples you started with and see if it's got under some of the examples, see if it looks like this. Maybe you can find one that will actually is actually set up to run on your board.
Isn't this Arduino C?
Yes, it is. That's why I'm saying if that's what you're running, then this might drop right in and work. But if you run a MicroPython, then you have to figure out a different way to do it. But
Yeah, this, let's, I'm gonna share my screen and walk through the one example that I dug up. Share screen, share. So this I found on Instructables, and he was using a slightly different board, but it was basically, you know, the same thing. And I put the link to his YouTube video in the chat. It goes through you know, the master and the slave, receives a verification, and the package sends a package with data. Master receives verification that has the data, and then indicates receipt to the slave. And so he doesn't share the whole. he walks through like pieces of the code. So this is like the setup display, and then this is start LoRa. And he does something interesting when his coding. He like has this master INO file, and then he has these separate files, and I didn't quite figure out how he's doing this yet, but anyway, let's see if we can figure it out. So here's his loop. Ever so often do a send. And
then right below he says receive. So it looks like, yeah, it sends it out and sits and waits for it to receive. So it looks like this is doing both directions.
right, so he's got the send and the receive. I'm assuming inside that whole
And
loop.
then right below it says void receive down at the bottom of the page there. So it looks like he's sitting there waiting for data to come back. Yeah, right there.
So he's checking his receipt.
On that code that I showed, it had a timeout field right on that. And I don't know if he's doing a timeout or not, if he'll just sit there and wait forever for it to come back in.
packet size, receive. How else can you get out of here? Yeah, I guess the only way you get out of here is if you actually receive something. So if you don't, if you don't receive anything, you would still, index is greater than or equal to 0. I wonder what index is all about. Index is the received index of set data. So
it could be as he's receiving, he's just counting the number of characters. So he's got something else that says, well, if it's a correct number of characters, then what he just said is greater than or equal to 0. So it's I don't know what he's doing there.
we retrieve the string that is after the set data, which is in this case is the data we're interested in. So we must always send we run an attempt to read the package of
So he's just verifying that what you said is what you're expecting, is some of the stuff he added on there.
if there are packages to be received. Send receive. And this is the slave. If
Do you have
received,
quick access to the code you're actually running? Just look at that and see what it looks like.
no, I don't have access to the boards and the code that are on the boards now, if that was the question.
Yeah, that's what I was wondering. And I don't know if these are the same, he's running the same libraries that I'm running or not. And I'm sure up the top somewhere he's going to tell you what he's running, but and my only reference is what it says on the Adafruit page. That's the stuff I was running on the one end.
Yeah, those are the includes that he has.
Well, that LoRa.h is that's what it's referring to, but I don't know which libraries. Maybe just search this page for library and see what library without a Y, and then you'll get singular or plural. Because somewhere at the top, he's going to say, go out and download these libraries and then take the code I got below and make it run. So if he's using the same library as I am, then the same statements that I have should work as far as the radio goes.
I think he's using these constants. So he's always passing these constants, I guess, back and forth. Anyway, I think your example is probably going to be a little bit easier to get my head around than this one. And you put that URL in the chat, did you?
I put the URL for the Adafruit stuff.
Yeah.
I'll check here and see if I've got my Arduino stuff, and there might be a chance it's on this computer, but I think it's actually on a Linux computer somewhere. Arduino.
And you went down to the RFM 9X library example, right?
I think so. So another thing to keep in mind, if you loaded somebody's library on this, and then you go to your Arduino, what's it want to do? New is available. No. Let me put this back up here again. Start screen. Go here. Get these out of the way. Make this big enough to see. So if you go under File, Examples, and then come down for the type of thing you're looking for. So let's go down. I don't know if this is big enough to read, but
No, I can read it.
so let's see, Adafruit, blah, blah, blah. But if you have the libraries loaded for your board, then under examples, there's a good chance there will be ready-made examples you can just click on and pull them up and run them. If you weren't aware you could do that. Oh, come on.
Yeah, I'm not sure if I checked there or not. It was the whole, plenty of the simple ones, you know, with just one send and here's what I got. It was the back and forth. Like there's some commands in there about in the Adafruit example that I think are new to me, around wait packet sent. That's looks like that'll be really useful. And there was the other one. Maybe it was that one that was the new one.
It doesn't look like it's loaded on this computer, so I'll have to go track down which computer it's on and see if I can come up with, you know, find my actual code.
You have so many computers.
You know, what I really have is a bunch of extra hard drives that as I pull them out, I just put them in one of those adapters so I can plug them in and boot from them. And as I upgrade them, then well, it's left on some other hard drive. So I got to go through a box of hard drives and find the right one.
That's funny.
Oh, one more thing I was just thinking about, you know, you were showing me that laptop that you're going to use for your lawn tractor. And I said, well, it's just like the one I've got. That one's old enough. You can flip it over on the back. There's a couple of tabs. You open it up and you can see the hard drive. You can see the RAM and everything right there, all the replaceable stuff. Whereas my new one, which is the one you've got's a ProBook. And I looked, yours was a ProBook 600 something. Mine's a ProBook 450. But it's still really accessible at this point. So I got another one that I bought that's a Pavilion, HP Pavilion, and they've got to the point where the battery is just just like a lithium battery pack, you know, the flat pack with some wires on it, and the hard drive is everywhere it says that you can put in the hard drives that are this big. I can't think what it's like the 2.5 inch. I can't think what they are. Anyway, it's got the replaceable hard drive in there. And it's also got the little slot you can put in the M2 flash drives, or whatever they're called. And nowhere does a document that's in there until I opened it up to look for that. I opened it up while I was in there. Hey, there's one of those sockets right there. But anyway, to get that one open, you have to pry all the tabs loose. So you got to go around risking damage to the point where you may not be able to get it put back together again. So now, you know, the modern ones, now they don't have their quickly replaceable battery. And if you want to swap out the hard drive, you got to tear it completely apart. If you want to add RAM to it, you got to tear it completely apart. So it's handy. The one you've got that you want to use is the one you chose, because that's much easier to work with.
You're right. There's there. I'm looking at another one that I've got here, and it's newer, but more of a pain in the ass, because you're right. You gotta. I have one of those pavilions at home, and on the side you'll see a bunch of scratch marks on the side where trying to pry it open was a pain in the backside.
Yeah, I think I've had mine open twice. I'm really afraid to do that, because then I don't want to have to duct tape my damn computer back together after I've destroyed it. So
I logged into my computer at home, and we just opened up Arduino to see if it has any examples for, I'm trying to remember what library. Well, there's a LoRa library here. It's got LoRa dump register, duplex callback. Duplex callback, that sounds like that's pretty complicated.
that sounds, yeah, that sounds like it's close to what you want.
That's using more professional language than I'm using.
Which I think duplex simply means you can send stuff back and forth at the same time. So it could be any of them that they have examples. They're not just single direction.
The serial print line says LoRa duplex with callback.
Yeah, the callback might be something important. So I don't know. Just depends how they defined it.
Let's see if I Google that here and if that comes up.
I think that's just terminology they made up, so it's not necessarily, industry standard of what they told you there.
Sounds fancy.
Yeah, it sounds fancy, all right, and that's the problem, that people like to make things fancy anymore and not necessarily tell you the right thing.
Yeah, I'm putting it in the chat.
Huh. For some reason, that link won't open on the computer when I click on it. Oh, there it went.
Sends a message every half second and uses callback for new incoming messages. Implements a 1-byte addressing scheme. While sending, LoRa is not listening. And using the callback method, you can't use any of the stream functions that rely on the timeout, such as read stream.
And about 6 lines down, it says this is by Tom Igo, and he's somebody either from the Arduino people or, yeah, right there. So it could be that I'm thinking that's probably he had something to do with the stuff that I'm running too.
Are you familiar with that name?
I'm familiar with the name, but he's either from Arduino or he's from somebody that does this stuff all the time. So this might even be the exact example I started with. Are you in a GitHub at this point? Can you
Yes.
back up a level and see what other examples he lists? Just click on examples there.
Yeah, these are the examples that are in my Arduino library for the LoRa include.
So I would say you've got everything you need there. You just got to figure out which one's appropriate to use.
Yeah, it's simple, right?
Yeah, yeah.
10 once a second is too aggressive.
I see they have one that's simply called LoRa sender. Oh, there's one called sender and one called receiver. That's one you started with?
That's the ones. I mean, I didn't start with these exactly ones, but those are the that's the hello world sort of deal.
Yeah. Yeah, probably there's one called duplex maybe is what you want, but what did that stuff? It said wait for. I remember what my code said that I was showing you. It said. It says, here, I'll just pop that in there. That and go to chat. So while you're in that GitHub, if you're still in there,
Mm-hmm.
again, okay, just cut that out and paste it into the search function on that GitHub and see if it. Actually, don't put the RF95 dot. Just put the wait for available timeout and search for that and see if it shows up. Because that RF95 they created an instance and that's just a random name they made up. Just go up the top there where it says search, the search bar at the top, and just put in that wait available timeout and see what shows up.
Why am I not seeing a search bar?
It's up in that black strip at the top. It just says search. Go over to your right.
Oh, my Zoom thing is in the way here. There you go.
Oh, that old problem, yeah.
Yeah, I mean,
So that's not a direct thing that showed up, I guess. The other issue is, since I'm following the Adafruit library, it could be they wrote a function called wait available timeout, so it's not in the actual main library. That might be another.
yeah, interesting. It's not getting.
Yeah, that thing right there that said there, if you click on that one, there might be people talking about, which library do I use? That might give you some information.
Yeah, his loop is this looks.
There's that statement right there up about 6 or 7 lines. It says RF95 dot wait available timeout 1000. That's the one. That's the magic line right there. So that it looks like whatever code you get right there is probably what I started with. So make sure you bookmark that page. And the question is whether or not they'll drop right onto your board and run. That'd be the next thing to look at. And this says Cytron technology, so it's not part of that when you searched on the other page, it took you to a new website here. I assume that Cytron is the same people that make the driver boards for the big motors. But they've got, apparently they're publishing extra code to talk to these types of boards. But before you dig into it too hard, I'll try to track down the code that I have, and we can see how much stuff I did, because I did things like converted the analog inputs into, figured out how to stuff it into bytes in those buffers and all that kind of stuff. But just to start with, you just take their example that just sends a hello message and sends a yes, I heard you message back and forth, and that, if that works, without making any changes to it, other than make sure your band is set up correctly and all that kind of stuff.
Mm-hmm.
And if that send messages back and forth, then that's a very good starting point. And if I find the code that I used, maybe at the top I was smart enough to say, this is the website I got it from. So that might be a good indication right there.
Yeah, that message seems to be a function specifically in this Radiohead class. Anyway, enough to keep me busy. The 8-bit one looks a little bit easier than the, or more organized. But the Cytron thing, I bet if I do a comparison, they're like a whole lot alike. If I go back to so this is where that weight was at. See what else they have. Holy cow, I don't think I want to page through their repositories. They have 261 repositories.
Yeah. And it could be they just copied them from other people too. That some people just collect repositories. But that does look like it's the same people who make the Cytron motor boards.
Hmm. Yeah, there's their It's just a repeat of their. Nope. Nothing. Can't tell. Same logo. That would be them. Interesting. Okay. Hey, hey. 20 amp motor driver or a 30 amp motor driver. There you go. There's their LoRa shield. Yeah, no LED on it. Looks like that's the antenna. LoRapedia. Haven't been to the LoRapedia.
Never heard of it. Might be worth looking at. I want to bookmark that one too.
Anyway, I bet I'm late for something. Oh.